In this video, we will see dry run of the code.
Now let's quickly check the dry run of this code. So this is my height of the buildings, right? These all are my building heights. The current length of the array is 12. Okay, so we have done this. I am in the function. I will create one right maximum and fill it with 0. So let make it my right maximum, and instead of filling with 0, I am simply putting like empty. Okay, so because I don't need to like again erase it then up to the value, so I am just putting with empty, right? So my this is my right maximum building. Okay, array, and I will create one variable. Let's suppose here water. Okay, and from I equals to height dot, first of all, this is done, this is done. Now this one, right maximum, the last element will be your height last element, so I will mention it. Okay, and now I will fill it from the last index. So n minus 2, that is 12 minus 2, that will be 10. So I will start from here. Okay, and I will fill it. How I will fill it? I will find the maximum of your my right maximum I plus 1. Okay, suppose this is I pointer, I plus 1 in height of I. So 2 and 1, which is maximum 2. I pointer will move here, and 2 and 1, which is maximum 2. I pointer will move here, and 2 and 2, which is maximum 2. So 2 pointer, I pointer will move here, 2 and 3, which is maximum 3. Then I 1 and 3, which is maximum 3. 1, then 3 and 0, which is maximum 3. Okay, then 3 and 1, which is maximum 3, then 3 and 2, which is maximum 3, then 3 and 0, which is maximum 3, then 3 and 1, which is maximum 3, and then 3 and 0, which is maximum, that is 3. Okay, so this will be my right maximum filled with the right maximum buildings on the right side, basically maximum height of the buildings on the right side. Okay, so this is also done. Okay, now I will take one variable, that is left maximum, and I will fill with the height of 0, so that is 0. Okay, and now let's start iteration. Okay, so start with 1. Left maximum will be maximum of left max and height of I. So 0 and 0, which is maximum. So let's start with I equals to 1, because we need to start from 1. So maximum, your left maximum and height of I. So 1 and 0, which is maximum, that is 1. Okay, now water will be method dot min of minimum of left maximum and right maximum of I. Okay, so now I pointer will be somehow here. Okay, like this. So left maximum and right maximum, which is the minimum of it, right? I need to find a minimum. So right maximum is 3, left is 1. So this is 1 is the minimum, right? And from this, you need to subtract the height of 1. If I subtract the height of 1, 1 minus 1, I will get 0. So right now the water value is 0 only. Okay, I will move my pointer I here. Okay, again, left maximum will be left maximum and height of I. Okay, my I pointer will be here. So which is maximum? Again, 1 is the maximum. Now I need to find minimum of 3 and 1. So minimum of 3, again 1. And now 1 minus height of I. So what is the height of I? 0. So 1 minus 0 will be 1. Okay, so I will add 1 here. Now moving to the next pointer, I will find out the maximum. So height is 2, left maximum is 1. So which is greater? 2 is greater. So I will update with 2. Now this is 2, right maximum is 3, which is minimum, 3 and 2. Okay, that is 2. And 2 minus the current building height, that is 2. So 2 minus 2, that will be 0. So I will update with 0. I will move my I pointer. I will move my I pointer here as well. Now left maximum 1 and 2, which is maximum 2 only. So I won't update it. Now 2 and 3, which is minimum, 2 is the minimum, right? So now from this minimum 2, I need to subtract the current building height, that is 1. 2 minus 1, that will be 1. So I will update with 1. And I will move my I pointer, and I will move my I pointer here. Now 0 and 2, which is greater? 2, right? Maximum is 2. Now 2 and 3, which is minimum? That is also 2. Okay. Now this this I am getting, right? Mat dot min of this I am getting 2. 2 minus 0 will be 2. So I will update with the 2 here. Okay, water. And I will move my I pointer here. I will move my I pointer. 1 and 2, which is maximum, 2. 2 and 3, which is minimum, 2. 2 minus 1, 1. So it will be 1. Moving my I pointer, moving my I. Now 2 and 3, which is maximum, that is 3. 3 and 3, which is minimum. Both are same. So you can take 3. 3 minus 3 will be 0. So I will update with 0. I will move my I pointer. I will move my I pointer. Now 2 and 3, which is maximum? 3. 2 and 3, which is minimum? 2. Right? This is minimum. 2. Now 2 minus 2 will be 0. So I will put 0 here and I will move here. My I pointer. 1 and 3, which is greater? 3 is greater. 3 is my left max so far. Then 2 and 3. So which is smaller? 2 is smaller, right? So 2 minus 1 will be your height of the water, basically area of the water. So I will add 1. Okay. And I will move my I pointer here. I will move my I pointer here. 2 and 3, which is greater? 3. 2 2 is here. So 2 and 3, which is minimum, that is 2. Here is the minimum. 2 minus 2, that is 0. Similarly, if I move here, okay, I pointer is here. 1 and 3, which is greater, 3 is greater. 1 and 3, which is smaller, 1 is smaller. 1 minus 1, that is 0. So here you can see the water collected only this region, this, and this. If I sum it, I will get the value as 6. So this is the dry run of the water, like dry run of this approach 2, and you will get an answer of 6. Again, you can see here. So you have taken one array right to maximum here, okay, and you are moving from height of length of -2 to 0, basically somehow nearly n times, okay, nearly n times. This is also nearly n times, okay. So time complexity again here big O of n, and space complexity will be big O of n because you are taking an extra array of size n, okay. So now let's see the next approach, the approach 2 that we have discussed. So now let's see the dry run of the second approach, where we have one L pointer pointing to 0, R pointer pointing to n minus 1. So n is 12 here. Okay, so n minus 1 is 11, and that is R pointer. L. So R pointer here. I will take one left maximum. So left maximum with 0. I will take one right maximum with 0. Okay, and water with 0. So while L pointer is less than R, yes, both pointer are less than, right? L pointer is less than R. So height of L is less than equals to height of R. Yes, 0 is less than equals to 1. So I will come here inside this if condition. Okay. And is left maximum height is greater than height of L. So left maximum is 0. It's not greater, right? So there is no water storage. I will simply update it and move it. So I will update it with 0. That is 0 only, and I will move it. Okay. Now again, I will come here L plus plus. That's why what I have done L plus plus. Now again, L is less than R. Yes, L pointer is less than R. L is pointing to 1. R is 11. Height of L is less than equals to R. So yes, the Lth building height is not less than but equal. Okay. So we are also deciding that we will move only L pointer. Now, is your left maximum is greater than height of L? Left maximum is not greater than, so there won't be any water collect. But if that's not the case, what you will do, you will update your left maximum with height of the L. You will update with 1 and you will do L plus plus. Okay. Now, again, left and R, which is smaller, height of the L building is smaller than height of the Rth building. Yes, it is. And is your left maximum is greater than height of the Lth building? Yes, that's condition. If condition is true, I will store the water will be left maximum minus height of the water. So left maximum is 1 minus height of the L, that is 0. 1 minus 0 will be 1. So I will get 1 here. Okay. And once I get 1, I will move my L pointer here. Okay. Now, is L and R, which is smaller, Lth building or Rth building? Now, Rth building height is smaller, right? So I will come under else condition. Okay. Is your right maximum is greater than height of the R? No, it's not. So simply update it and move. So I will update with 1 and I will do R minus minus. I will move it here. Okay. So this will be my R pointer here. Now again, Lth and Rth, which is smaller, both are equal, right? So if equal, I will come here, height of the L. Is your left maximum is greater than your Lth building? Left maximum is not greater than. So what I will do, I will update it and I will move it. Okay. Now again, Lth building height, Rth building, which is smaller? Lth building is smaller. Okay. Lth building height is smaller. I will come here. Is your left maximum is greater than your Lth building? left maximum is greater than height of the L. Yes, that is. So store the water. Water will be 2 minus 1. That will be 1. Okay. And you will simply move it. So you will simply move it. Okay. Now Lth and Rth, which is smaller? Okay. So again, Lth building is smaller. Yes. So what I will do? I will check is my left maximum is greater than height of L. Left maximum is greater than height of the L. So update the water. Left maximum minus height of L. 2 minus 0 will be 2. And I will move it L plus plus. Again, L and R, which is smaller? Lth building or Rth building? Yes, Lth building is smaller. Is your left maximum is greater than height of the Lth building? Yes, it is greater. So 2 minus 1 will be 1. I'll update it and I will move. Now, see, Lth building is at 3. Rth building is 2. Which is smaller? Rth building. So I will come under the else condition. And I will check, is my right maximum is greater than height of the R? Right maximum is 1, height of the R is 2. No, it's not. So what you need to do, you need to just update it and move it. So I will just update it and move it. Okay. Now Lth and Rth, which is smaller? Again, Rth building is smaller. Okay. Is your right maximum is greater than height of the R? Yes. Right maximum is 2. Rth building height is 1. 2 minus 1, that is 1. So I will update with 1 and I will move it. Okay. Now again, Rth building and Lth building, which is smaller? Rth building is smaller. Is your right maximum is greater than your Rth building height? No, it's not. So update it. So if I update it, it will be same, right? 2 only. I will simply do R minus minus. I will be. Now, is your L pointer is less than R? No, it's not. Both are pointing to the same element, same height of the building. So I will stop here. And in the last, I will return my water here. I have not returned the water. Sorry, my bad. I will return the water here. And what will be the water? That will be 0 plus 1 plus 1, 2 plus 1 plus 1. That will be 6 again. Okay. So this is how you calculate it. Okay. Again, L pointer and R pointer both are moving from left and right. So if I'm taking the worst case, suppose one pointer is remain still here and L pointer from here till here. Okay. So it will complete a distance of n elements. Okay. So it is depending on the size of the height of the building. So basically the time complexity will be big O of n. We are not taking any extra space. So space complexity will be big O of 1. Okay. So this is how you can solve one of the most famous problem, important problem, I will say. Okay, where a pre-calculation is needed. Okay, with the two approaches. Okay. So please try out this problem. Go to the lead code, solve it by both the approaches, and see how much you have. Like, what is the percentage of the people you are baiting on the lead code? Okay. Thank you, and let's connect on the next.